Hello, welcome to my channel. We are discussing the magnetic effect of current. In the continuation of the topic, today we will discuss a force which acts on a charged particle moving in the magnetic field. What is that force? When it will be maximum, what is its direction? When it will be minimum, what will be its direction perpendicular to the velocity and magnetic field. All this we will discuss today, and this force is called Lorentz force. That is a magnetic force acting on a charged particle moving in the magnetic field. We will continue, and before that please subscribe my channel and press the bell icon so that you stay connected with more videos, and previous videos you will see the playlist. Today I will discuss the Lorentz force. Previously we have seen that if the current is flowing through a conductor, magnetic field is around it. Whether the current is flowing through a straight conductor, it is of circular shape, any of the shape, straight one of finite length, so many, and we have seen the derivations using Biot-Savart's law and Ampere's circuital law. We have seen inside the current carrying wire what will be the magnetic field, and also in the pipe, hollow pipe of conducting material, copper pipe, no magnetic field inside. We have seen all this, but still we know that magnetic field is produced by the current carrying conductor as well as by the motion of charged particle. Whenever the intrinsic particle like electrons, when they move, they produce magnetic field. Magnetic field is a characteristic associated with them like their charge and mass. What happens that if an electron, suppose this is the electron, it moves in the circular orbit of radius r. This is the question also asked in the examination, that what will be the magnetic field at its center if it is the electron moving with in the radius r circular orbit, and its angular velocity is given omega. Find the magnetic field at the center. How will you find magnetic field? You know the electron constitute the current, and current is given by this E upon T, Q by T, electronic charge. And what is this T? You know T is 2 pi upon omega. This will become, you should know the class 11th 2 pi upon omega angular speed if angular speed is given. Simple. What will be the magnetic field? You know magnetic field at the center due to circular loop, mu naught I. That is why I am revising the previously taught topic in the form of questions, that this is the magnetic field at the center. Then put the value of I, you will get the magnetic field in terms of angular velocity. What will you get here? This is mu naught E omega upon 4 pi r. This is 2 pi, this will make. So why I have given this description, that elementary charged particle also produces magnetic field, and magnetic field is the basic characteristics of the elementary charged particles. Today's topic is that whenever charged particle in motion, it produces magnetic field, but whenever it moves in magnetic field, external magnetic field, what happens? And this is the Lorentz force. I have shown here that in this figure, 3 axes, this is x, this is y, this is z. In both the figures, this x, y, z, 3 axes. How can you get 3 axes in your hand? This is forefinger, middle finger, thumb. Look, these all are visually perpendicular. So here I have shown here, this is the forefinger, this is middle finger and thumb. So you have to use it. That's why I am saying at the blackboard, this or the board or a plane, you cannot show the 90-degree angle, but you have to assume. You can assume you can see these 3 mutually perpendicular direction in a room where you sit, length, breadth, height. So here I have shown that this is x, y and z axis. Then if the charged particle is moving and it passes through a point P, then if the charged particle velocity is suppose in this direction, magnetic field is in this direction, so at point P it experiences a deflecting force sideways. Sideways means the perpendicular direction of its motion. This force is called Lorentz force. So how will you define Lorentz force? This force, Lorentz force, is defined as the force experienced by the motion of the charged particle in the magnetic field. And if the charged particle moves in direction other than x-axis, suppose that this is x-axis, charged particle is moving in this direction, magnetic field is in this direction. So at angle theta with the magnetic field, this charged particle is moving. Then also we find that this force is perpendicular to the v and b, and this v sin theta is the component of velocity at which we find that along x-axis the velocity component. So what do we observe? That the force is directly proportional to b, force is directly proportional to v sin theta. So on combining, what will you get? qvB sin theta, the magnitude of this force, or in vector form you can write F equal to qv cross b. So this force is called Lorentz force. And how will you find that when the force will be maximum, zero, minimum? So if you know theta is the angle between velocity of the charged particle and magnetic field. So in the first case, suppose we discuss that if theta is 0, then in what direction charged particle is moving? Theta 0 means, look here, this is theta, then theta 0 means in the direction of magnetic field. What will you write? You can say in other words, in questions. One time it is asked that theta is 0. Secondly, they will say that V is parallel to B. And you know, if theta is 0, then sine 0 is 0. Therefore, F will be 0. So, 0 will be the force when the charged particle is moving parallel to the magnetic field. No force acts. This is the minimum force. What happens in the second case? If theta is 90 degree, then you know sine 90 is 1. Then what will be F? F will be F maximum, and F maximum will be qvB. So in the vector form, we can write that F equal to qv cross b. This I have written here, this in the vector form. And how can you define B, magnetic field? B will be here equal to F upon qv. Now look here, that what is the basic difference between this magnetic field and electric field? Suppose you want to determine electric field at any point. What do? You have read earlier in electrostatics that in the uniform electric field, if there is a point P, we want to determine the magnetic field, electric field at this point. Then in the uniform electric field, if we place a test charge here, then what happens? This test charge experiences a force in the direction of field, then this force is equal to this F is equal to this Q naught into E. Look, this is electric field, vector quantity, the force is in the direction of electric field acting at a unit charge placed at that point. Suppose this point is P. Why not you find the magnetic field in this way? The reason that single isolated charge exists. but monopoles in the magnetic field is due to a magnet. So every magnet is a dipole. Monopoles do not exist. So what we have to do? Here we have shown that the charged particle is moved in the uniform magnetic field, and when it moves parallel to the magnetic field, in this case it does not experience any force, and when it moves in any of the direction theta angle, this force exists. This angle theta, you should know the component. This will be v sin theta, and along the b, that will be v cos theta. So in this way you should know what is the component. So v sin theta is the component perpendicular to the f. Look here, the magnetic field, how it has been defined. If its unit is 1 Tesla, then it is force experienced by the unit charge is 1 Newton, and 1 Coulomb charge experiences a force of 1 Newton when it moves perpendicular to the magnetic field with the speed 1 meter per second. I am saying again, 1 Tesla is that magnetic field in which 1 Coulomb charge experiences a force of 1 Newton in a direction perpendicular to both its velocity and magnetic field, and its velocity or speed is 1 meter per second. Look that this magnetic field is defined, and how will it define the direction of magnetic field? Magnetic field is the direction in which the moving charge does not experience any force. So in this direction, if you see the direction of motion is along the B, there is no force. That is, if theta is 0, then force is 0, and this is the direction of magnetic field. How will you find the direction of Lorentz force? Using right hand screw rule, as it is the cross product. How will you use the right hand screw rule? That if the screw is taken in the right hand, and the curling of the all the fingers is towards B from V, look, from V to B, then this is the thumb, the advancement of the screw, the head of the screw, or the thumb denotes the direction of force. Listen again, if the right hand thumb, in the right hand, thumb and curling of the fingers, you know, perpendicular to the thumb, curling of the fingers, and curling of the fingers denote the angle from V towards B. This is qv cross B. Then curling of the fingers from V to B, then the thumb gives the direction of force. Another way to determine this Lorentz force direction, using Fleming's left hand rule. So don't get confused between left and right. Left hand rule, this forefinger, middle finger and thumb, they are kept mutually perpendicular, and a forefinger denotes the direction of magnetic field, and middle finger denotes the motion of positive charged particle, velocity of charged particle. Then thumb gives the direction of Lorentz force or force. So in this way you have to define the direction of magnetic force, that is called Lorentz force. And how will you define the Lorentz force? When a charged particle moves in a magnetic field, then it experiences a force called magnetic Lorentz force, provided the velocity and magnetic field should not be parallel. So if other than parallel to magnetic field, any of the charged particle moves in the magnetic field, uniform magnetic field, it will always experience a force. Finally, the force and velocity, these are the two perpendicular quantities always, and force and magnetic field. You know, force is perpendicular to V, force is perpendicular to B. What does this figure show? That force is always perpendicular to B and V, and this is the maximum force because angle between B and B is 90 degree. Otherwise, what this F equal to, what is this F? this is qvB sin theta. This is V sin theta, this is B, this is F. So in this way, what is Lorentz force? How will you determine its direction? When it will be minimum and maximum? I told today. Thank you. In the next video, we will discuss further.